But this is the second part of our partial decomposition, right? If it says to write the form of partial fraction decomposition but don't solve, the only thing they want you to do is write out your little pieces of your fractions with your numerators, A, B, C, whatever. So the first thing we're going to do in this case here is to factor the denominator. So what are the factors of 9, positive 9, that multiply to give me 9 but add to give me 10? It'd be x plus 9 and x plus 1, right? Okay. So now how many pieces am I breaking this fraction into? 2 pieces. I have the denominator of x plus 9 and I have the denominator of x plus 1. So I give my numerator, the first one is going to be A, the second one is going to be B. Now if you guys wrote x plus 1 under A and then x plus 9 under B, that's fine, just as long as you keep at the end that you put A with A, B with B. But this is where they want you to stop. There's going to be questions on your exam that are just like this, just set it up. Now if we go one more step to solve, that's a different story, but if you're just setting up, that's where we're going to stop right there. Everybody with me on that? All right, now you're not going to have one of these probably, but I just want to make sure that you guys see this. If you notice, this is the same binomial and it's to the third power. Does everybody see that? So what this is really saying is x plus 3 times x plus 3 times x plus 3. All right, how many pieces is that? How many pieces of a fraction would that be? Oh, I'm sorry. Is that I thought that was a 3. The way that I circled it so big. I'm sorry. Yeah, you're right. X plus 1, and x plus 1. Yeah. So when you pull your pieces apart, there's 3 pieces, right? You guys see that? What do you notice about the 3 pieces, though? They're all the same. This only happens, guys, when they're the same. All of them are the same. So my first denominator is x plus 1. Your second denominator and your third is not just x plus 1 and x plus 1 again. This second denominator, since it's the second one that is the same, is going to be squared. And then the last one is going to be what, do you think? To the third. And then you would give yourself A, B, and C. I don't think there's anything on the final like that. I have to go back and look. But that only happens when your denominator is a multiple of the same binomial. You're not ever going to have to work any of these out to where you're finding, you know, like to solve. You would only have to go this far setting up. But if you had x plus 1 to the 4th power, how many fraction pieces would you pull it into if it was to the 4th power? 4 pieces. So your first denominator would be x plus 1. The second one would be x plus 1 squared. The third denominator would be x plus 1 to the third. The last denominator would be x plus 1 to the 4th. Just goes like that. But I don't think you guys are going to have that, so don't worry about that. All right. Another one that says set up but don't solve it. How can I rewrite my denominator so they're all just singular binomials? This is the same as x minus 1, and then what? What does x minus 2 quantity squared mean? How many x minus 2's are there? 2. So if you were going to break your fractions up, how many pieces would you have? 3 pieces, right? Your first denominator would be the x minus 1. What's your second denominator going to be? X minus 2. What's that last denominator going to be since there's 2 x minus 2's? X minus 2 squared. Good. This would be A, B, and C. You're not going to have to go any further in the solving of that. I just want you guys to see whenever you have something that is raised to a power, you have to account for it under every numerator, but every time it has to go up one exponent. Like you have one of them and then the next one squared and then whatever it to the highest power. Just want you guys to see that. You probably will not see it anywhere. All right, let's do this last problem and then I'm going to let you guys get going on your work. We're going to solve partial fraction decomposition. We're going to solve this whole thing. So what's the first thing I need to do? Factor the denominator. What are the factors of negative 40 that multiply to give me negative 40 but add to give me negative 3? Negative 8 and what? Positive 5. Perfect. I'm going to go one more step just to help myself out, to remind myself, and I'm going to figure out what my two x's are going to be that I'm going to plug in. They're going to be positive 8 and negative 5, correct? All right, so let's set up our partial fraction decomposition. I have two pieces. What are the two pieces of my denominators? One is going to be x minus 8, and the other one is going to be x plus 5. Agreed? Okay, good. I have an a and a b. So now I say, okay, there's my setup. Now I need to solve it. So I look at that first fraction. I have x minus 8. What am I missing? X plus 5. Good. My second denominator has x plus 5. What is it missing? X minus 8. Perfect. So now I'm going to write my equation that I'm going to use to solve this. And I'm going to say x plus 3 equals a times x plus 5 plus b times what? X minus 8. Now when I go and I substitute in the two zeros that I found, what should happen to one of my letters? One should cancel out. So I'm just going to go over here and say, okay, we're going to solve with x equals 8. So I have 8 plus 3 equals a times 8 plus 5 plus b times 8 minus 8. You guys with me? All right, what's 8 plus 3? 11, good. And then what is 8 plus 5? 13. What's another way I can write a times 13? 13a, good. And then what happens with 8 minus 8? It's 0, and then b times 0, so I'm left with this. Now what do I do? Divide both sides by 13. And I get that a equals 11 over 13. Did we do anything yesterday with a fraction? No, it's not any different, I promise. Some of you are like, wait, why isn't it working pretty? It's okay. Let's go over here to the second one. I'm going to work the same problem out, but I'm going to substitute in what? X equals negative 5, right? So negative 5 plus 3 equals a times negative 5 plus 5 plus b times negative 5 minus 8. Agreed? Okay, so, excuse me, what is negative 5 plus 3? Negative 2 equals, what's negative 5 and positive 5? 0. So then 8 times 0, this is gone. So now I have, what's negative 5 and a negative 8? Negative 13, right? So I have negative 13b. Now what? Divide both sides by negative 13. What's a negative divided by a negative? Positive. So b equals 2 over 13. So let's go back to our setup. My setup was a... Yeah, I forgot to put the 1, I'm sorry. A over x minus 8 plus b over x plus 5, right? Now you guys are like, wait a second. It's a fraction. What are we supposed to do with that? No worries, guys. No worries at all. My a value is 11 over 13, and then I have over x minus 8, plus, what's my b value? 2 over 13 over x plus 5. That looks funny, doesn't it? What in your numerator, what is 13 in both cases? What part of the fraction is it? It's the denominator. So just take this, guys, and put it in the denominator. That's okay. So this would be 11 over 13 times x minus 8 plus 2 over 13 times x plus 5. If it comes up that you have a fraction, whatever the denominator is of the fraction, you just put it in the denominator of your answer. It's no big deal. If you left it like this on a test or a quiz, I'd probably give you credit. But your final is going to be multiple choice. So you need to be able to pick the answer that is correct. Everybody see that? You guys all right? Okay. All right. That's all I have for you guys. You have 5 problems now. I will work all of them out. I promise. I'll do 1 or 2 of them with you in class tomorrow. Give you guys the opportunity to work on them over the weekend. I will post the answers so you can see them. And then I won't be here for your class Monday morning because I have a doctor's appointment, but I'll be here on Tuesday for the review. So I will make sure that you guys are prepared for your test on Wednesday.